This is lesson 2.5, solving compound inequalities. The essential question here that we're asking is how can you use inequalities to describe intervals on the real number line? A compound inequality is an inequality formed by joining two inequalities with the word and or the word or. Like on the example on the left, the graph of a compound inequality with and is the intersection of the graphs of the inequality. The graph shows numbers that are solutions of both inequalities. So like with x is greater than or equal to 2 and x is less than 5, you're just going to look and it's the interval that both have in common. Now as far as the or, you've got one going one direction, one going the other way. You just graph both of them right here. So let's look at an example here. Write each sentence as an inequality and then graph each inequality. Let's see. A number x is greater than -8 and less than or equal to 4. So x is greater than -8 and x is less than or equal to 4. So to graph that, I'm going to look here on the graph and it's going to be x is greater than -8. So I've got a circle. We'll say this is -8 right here. Got an open circle. Let's see, 8, 7, 6, 5, 4, 3, 2, 1. Let's go by twos. 6, 4, 3, 2. There's 0. And right here's 4. And there we've got a solid circle. So we're going greater than -8, which would be going this way, and less than 4, which would be going this way. So it's just going to be these right here. A number y is at most, so y is at most, that means it's going to be less than or equal to 0, or at least 2. Remember with the or, we're going to have two different arrows going two different directions. So let's see. Y is less than 0. So let's put 0 right here. So this is 2. So y is less than or equal to 2. So it's going to be a solid circle going this direction. Oops. That's maybe a little too. Let's go this way. Or it's going to be a solid circle again on 2 and going this way. So it's going to be all numbers except for anything greater than 0 and less than 2. So y is less than 0 or y is greater than 2. If you look at example 2, solving compound inequalities with the word and. So kind of like that first one with the word and. So let's see. Each inequality. These -4 is less than x minus 2, which is less than 3. So when we have an and, you can sometimes have it look like this, where it's got the two inequalities there. The best way to solve this is to separate the compound inequalities into two inequalities. So you're going to have -4 is less than x minus 2, and x minus 2 is less than 3. So when we're looking at solving this, to get x by itself, I need to add 2 to each side. And I'm going to get negative 2 is less than x. And then over here I'm going to add 2. And I'm going to get x is less than 3. So if I put this as 0, so negative 2 is going to be an open circle. And x is greater than negative 2, so it's going this way. And then we have another open circle at 3, and x has to be less than that, so it's going to be right there. Open circles from negative 2 to positive 3. Let me change colors here so that we can see the difference here on this one. We've got negative 3 is going to be less than negative 2x plus 1, which is less than or equal to 9. So again, I'm going to write two different inequalities. Negative 3 is less than negative 2x plus 1, and negative 2x plus 1 is less than or equal to 9. So to solve these inequalities, first, let's look at the one on the left. I'm going to subtract 1 from each side. So I'm going to have negative 4 is less than negative 2x. Then I'm going to divide by negative 2, which means 2. Those cancel out and I've got x. But remember, I divided by a negative number, so I need to flip the inequality. So 2 is greater than x. Now again, subtract 1 from each side, and I get negative 2x is less than or equal to 8. Divide by negative 2. That cancels out, and I get x and negative 4, but remember to flip that sign. So x is greater than or equal to a negative 4. So now on graphing this one, I need to make sure that I've got a closed circle at negative 4. So let's just call this one right here 0. So negative 4, 1, 2, 3, it's going to be right there with a solid circle. And at positive 2, I'm going to have an open circle. And x is greater than the negative 4, but less than the 2. So it's going to be the line connecting those two circles. So let's look at example 3 here. We have solving compound inequalities with the word or. So now I've got 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. So first I need to solve each of my equations. I'm going to add 5 to each side here first, remembering to get rid of what's added or subtracted first. And I will get 3y is less than a negative 3. Divide by 3. And I'm going to get y is less than negative 1. Now for the other one, I'm going to rewrite it over here. 2y minus 1 is greater than 5. So I'm going to add 1. Those cancel out. I get 2y is greater than 6. Then I'm going to divide by 2. And y is going to be greater than 3. So y is less than negative 1, or y is greater than 3. If this is 0, less than negative 1, I've got an open circle. and y is less than. So we're going this way. And y is greater than 3. Again, an open circle on 3, going this way now. So how would we do that in a real-life application here? Modeling with mathematics. Electrical devices should operate effectively within a specified temperature range. Outside the operating temperature range, the device may fail. Write and solve a compound inequality that represents the possible operating temperature in degrees Fahrenheit of the smartphone. So I've already put the equation here for you. Celsius equals 5/9 Fahrenheit minus 32. So first we need to understand the problem. You know the operating temperature range in degrees Celsius. You are asked to write and solve a compound inequality that represents the possible operating temperatures of the smartphone. Then you're asked to describe the situations outside of this range. So first off, we're going to make a plan. We're going to write a compound inequality in degrees Celsius, and we need to use the formula to rewrite the inequality in degrees Fahrenheit. Then solve the inequality and describe the situations. So let's solve it. We know that right now for this inequality, we've got 0 is less than or equal to Celsius, which is less than or equal to 35, because we know it operates between 0 and 35. Well, to rewrite that using Fahrenheit, we're going to put that formula in for C. So 0 is less than or equal to 5/9 times F minus 32, which is less than or equal to 35. Now, you can solve an equation by just doing an inequality like this, a compound inequality, by doing whatever you do to, like the center, you do to the left and the right. So like here, to get rid of this fraction, I'm going to multiply by the reciprocal. So by 9/5. And whatever I do to the center there, I'm going to do to either side. Times 9/5. So 9/5 times 0 is still going to give me 0. Is less than or equal to F minus 32, which is less than or equal to, let's see, 63. Now to get rid of the minus 32, I do the opposite, which is to add 32. And I'm going to get 32 is less than or equal to the F, which is less than or equal to 95. So that's going to be your compound inequality for this equation. Now the other part B, asks you to describe the one situation in which the surrounding temperatures could be below the operating range and one in which that it could be above. So if it was below, so we're looking at below 32. I mean, hello, that'd be a winter here in Indiana, right? What about an operating system of the greater amount, which is 95? How about in a desert? If you were in a desert during the summer, that would be above 95 degrees. Alright, when you're done, make sure you show me your notes and get the clever assignment done. Thank you.